So hey guys, welcome back to the channel. This is a physics buddy, and in today's session we're going to talk about another important topic from electricity and magnetism unit, which is Coulomb's law. We also talk about the superposition principle and different types of electroscopes. So this channel has covered so many different units from your AP Physics-2 curriculum. If you are looking for anything which is related to your curriculum, just let me know in the comment section. Stay tuned for more upcoming unit coverage, and let's start.
So let's start today's session.
Okay.
So in the last class, we talked about methods of charging and how can we actually induce charge on a metal surface if it is neutral. So today we'll move forward. Did you try the questions I gave you in the last class?
Yeah, I did.
Any confusion in any one of them?
No, I was able to solve most of them. Some of them, yeah.
All right. If you have any problem or any difficulty in solving any questions, just let me know.
Okay.
Okay. Yeah. So this is just for knowledge. Whatever charge that is going to be induced on a metal surface or a metal object, that charge can be calculated using this relation. Here, there is some constant which is called permittivity. We'll talk about it, what exactly it is, in today's session only. So you can remember this particular relation if it is maybe asked, although this is just for knowledge. Although, just try to answer this question. This question says, which method of charging does not allow the creation of charge without opposite polarity? So this is the important term here. So try to answer it. Which of the following methods which we have studied so far, out of this, which is responsible for generating charge on the metal surface without creating opposite polarity? Think about it.
Induction.
Not really. In induction, what happens is that we just bring a charged conductor near a neutral body, and because of which charge induced in such a way that equal charges are induced on the opposite side. So here there is an opposite polarity. So it is not the correct answer. Similarly, friction is also again not a correct answer because here also the polarity creates. But in conduction, we just induce charge by physically touching the two metal surfaces such that a small charge is being induced on the metal surface by gaining from the other body which is charged already by equal distribution. So just remember this particular thing as well. Now the next topic we have to study about is electroscope. So as I saw in the PPT which you shared with me, there was two topics that we need to discuss. One is electroscope and that is Coulomb's law. Next is Coulomb's law. So let's talk about what is electroscope. So electroscope is basically a device which was invented by again a British physician, William Gilbert, in around 1600, or you can say in 17th century. Way you can say way early than we ever expected it. So it's 21st century now, almost 400 years back this thing was discovered. So electroscope is basically a device which helps us to detect the charge on any object. So if there is a charge on any object, it can be measured by or it can be detected by electroscope. So how it works and what are the different type of electroscopes we have, we'll talk about this. So you just need to understand this thing that for centuries it has been defined as a device which is made up of conducting material and used for detecting and testing presence of ionizing radiations or electric charge in a body. So it was believed for like hundreds of years that it is just here to detect the presence of charge on a charged body, although it works like that only. It is used to, we can say, detect the presence of ionization radiation or electric charge in a body. Also, it helps us to identify and compare the magnitude of charge as well. Like how and what amount of charge is there and how we can actually compare the magnitude of charge. Similarly, it also helps us to calculate the force between the two charges. It also detects an relative amount of charge that is there on the metal surface. So these are the some uses of electroscope. Then we have three particular types of electroscope that was discovered. The first is fifth wall electroscope, then we have gold leaf electroscope, then needle electroscope. So out of these three types, we have to talk about gold leaf electroscope. So basically, this is in your syllabus, and let's talk about what gold leaf electroscope is. So it was invented by Abraham Bennett in 1787. This electroscope is comparatively more sensitive than a fifth wall one. So comparison to the other electroscopes we have, this one is more sensitive. Like it can detect charge more easily. Whenever you read or find this term in any particular instrument, it simply means sensitive means that this particular device or object is more efficient in its particular job, or it can do its work more efficiently than the other ones. So that is what sensitive means, because we are going to use this word again and again for studying different type of objects or different type of instruments. So what happens here in a gold electroscope is that it consists of a vertical conductive rod like this. So this is a vertical conductive rod, this one, which is being coming out into the whole device, and on the top of it there's a gold leaf, as well as at the bottom of this vertical rod there are one gold leaf and other, you can say, a brass strip. So these both are somewhat gain charge if it is there, and the rod is generally made up of brass. So what happens here is it consists of a vertical conductive rod with a metal ball on the top and two thin and parallel strips of gold leaf attached at the bottom. So to prevent the gold leaf from draft of air, it is being kept in a glass bottle. That is again an important thing to remember. So in order to avoid any other medium that can affect the charge lying on the surface or the object which we are bringing near to the gold leaf that is attached at the top, we just keep the whole device or whole instrument in a glass bottle, so that inside it we can make it vacuum, as there is no air or medium inside it. So what happens here is that how we actually used to detect the charge using gold leaf electroscope. We just bring the body near to the brass cap of the electroscope, which is at the top. If the gold leaf diverges outward, the body is electrically charged. However, if there is no divergence takes place, we can say the body is not charged, or you can say it has no charge. Now just observe the diagram. So this is the diagram, and here you can see if these two strips are separated by a certain distance. So we can say that the body must have some charge. Like for example, if you just brought a body close to it and it has some positive charge on it. So what happens here is this positive charge will, through the gold leaf at the top, will pass to the bottom inside the electroscope. And as these two strips will get electrically charged, so we know that the positive charge will repel. So automatically these two gold leaf will diverge. And this shows that the body which is being closed or which is being brought to the object or the electroscope has charge in it. So repulsion or the divergence shows that it has charge, and if the body is electrically neutral or it has no charge, it will stay parallel to it, like there is no divergence. So you can see here what we are going to do is, first of all, charge the electroscope positively, then test the body under the consideration to the brass cap of the electroscope. If the divergence of the gold leaf increases, then the body is positively charged. However, if divergence of gold leaf decreases, then the body will be negatively charged. So this is how we just used to identify or analyze the presence of charge on a given object that we are bringing close to it. So here you can see we just make it positively charged initially somehow. If it came positively charged conductor, so the leaves will automatically diverges and the divergence increases. Similarly, the negative one is brought, so automatically what happens is divergence decreases, or you can say it will become a little closer in comparison to the initial one or the first part. So this is how electroscope works, and just need to remember the theoretical portion about it. There is no such problems that came from this electroscope particular thing. So any question which is supposed to come from this particular topic will be specifically, you can say, related to the theoretical portion. So just understand what exactly and how electroscope works. Does this make sense?
Yeah.
So Coulomb's law basically help us to identify or find that how much force, or you can say with what force, a charge can attract other charge or a charge can repel other charge. So this is a law which actually help us to identify or to find electrostatic force, which is also called electrical force. So according to this law, whatever electrostatic force acting between the two charges is somewhat directly proportional to the product of charges. So if I suppose that this is the body which has charge q1 and this body has charge q2, according to this law, it says that the electrostatic force is directly proportional to the product of charges, and it is inversely proportional to the distance, square of distance between the charges. So that is what you need to understand here. So when we combine these two equations, we simply get that electrostatic force is directly proportional to the product of charges per unit square of distance between them. So when you remove this proportionality sign, or in any law, when we are removing this proportionality sign, we get a constant. And here that constant is represented by K. This constant is also called proportionality constant. And this proportionality constant has a fixed value for vacuum, or you can say for no medium. So this proportionality constant K has a fixed value known as 9 into 10 to the power 9 Newton meter square per Coulomb square. Now again, remember this value is specifically for vacuum or no medium, you can say. If there is no medium or there is a vacuum, then the K must have this particular value. Now this K can also be written as 1 over 4 pi epsilon naught. You must have seen it in your class. This epsilon naught is something we call permittivity. Now, what is this permittivity? So, permittivity basically it's a word, or you can say it's a factor which actually defines the property of a medium. Like for example, if we have just kept these two charges in air, so air must be a factor which is actually affecting this force, and that factor, that by what factor it is going to affect the force, it is represented by permittivity or epsilon naught. So for vacuum, epsilon naught again has a fixed value which is supposed to be 8.85 times 10 to the power minus 12. And if we talk about its unit, it's the reciprocal of this particular one. So you can say per Newton per meter square Coulomb square. That is the unit of epsilon naught. And this unit and this particular term, this particular value is specifically for again vacuum. If there is any other medium, the value of epsilon naught will change, and we can say that value of epsilon naught will become epsilon m. So for any other medium, we can say for any other medium, epsilon m is given. But what happens in most of the cases is that you don't actually get epsilon m. You get a value known as dielectric constant. Let's talk about it. So, for any other medium, epsilon naught is replaced by epsilon m. So, K will be changed to 1 over 4 pi epsilon m, where this epsilon m is representing permittivity of a given medium. And in most of the cases, or in most of the problems, we don't actually have this value. But instead of this, we have another value which is called dielectric constant. And it is represented by somewhat this particular symbol. So what this dielectric constant is? So dielectric constant is basically a ratio of epsilon m to the epsilon naught. That is, it is a ratio of permittivity of a given medium over permittivity of free space or permittivity of vacuum. So this is that one such relation that you need to remember if it is there. So very less chances, but yes, it can be asked. So for any other medium, the relation for force will change. And finally, we can say electrostatic force will be 1 over 4 pi epsilon m q1 q2 by r square. Now this epsilon m will be replaced, and we can write in place of this epsilon m 1 over 4 pi epsilon naught times this dielectric constant K. Again, it is a small one. It is basically a symbol. So this electrostatic force in this particular medium, let me just resemble it using F dash. So here, if you just observe its value, so 1 by 4 pi epsilon naught Q1 Q2 by R square into this. So ultimately, this Fe dash will automatically become Fe by K. So if for any other medium, we have to find the force, we just need to divide the force that is acting between the charges for vacuum by the value of the dielectric constant. So this is the electrostatic force for any other medium. So an important thing to remember, and you might observe that this will help you to solve so many questions. So this is electrostatic force in other medium having dielectric constant K. So that is what we have to talk about Coulomb's law. Now remember the relation K Q1 Q2 by R square, where K is 1 upon 4 pi epsilon naught. And for any other medium, it is 1 upon 4 pi epsilon m. So there are few things that we need to understand about Coulomb's law, that whatever force the two objects will be experiencing, the forces are going to be same. Like if this is one object, this is another object having charge Q1, having charge Q2. So whatever force is acting between them, or whatever force each object is experiencing, magnitude wise, these forces will be equal. And we can say that if it, as we know, it is a vector quantity, so these forces must have some direction. So as they always act in the opposite direction, so the nature of the force will be represented by F21 must be equals to negative of F12, because where the negative sign is actually representing the direction. And through this, we can also say that this is an action reaction pair from Newton's third law. So Newton's third law says if there is an action, there will be an opposite reaction. And this opposite reaction is here represented by this particular relation F21 is equal to negative of F12. Again, this law is defined for point charges. If the body has certain dimension, if the body has certain size, shape, then we cannot apply this relation directly. That is again you need to remember. It can be asked in some conceptual question which is being represented by a given question. Again, third point that you need to remember, this force always acts along the line joining the two forces. So basically, if they are the two objects having some charge, so whatever line joining them is there, the force will always act along this line. So line joining the two charges along this line only, the force is going to act. It is a central force. You can remember it. It is a central force which leads to the conservation of momentum as well as concept of center of mass. Also, this force is conservative in nature. This is an important term. Conservative forces are those forces which doesn't depend upon the path. They only depend upon the initial and final position. So what conservative forces are and how they do actually works. If it is required, I'll explain you in detail. As of now, just keep this term in mind that Coulomb's law gives electrostatic force and this electrostatic force is conservative in nature. Similarly, the force between any pair of charges is independent of any third charge present. Like for example, if there are two charges Q1 and Q2 and there is another charge Q3. So whatever force acting between these two forces, these two charges will never get influenced by the presence of third charge. Although the net charge at any given net force at any given point will be different, which we are going to calculate in today's class only, but it will not going to influence the charge, it will not going to influence the force acting between these two charges. This is what this point means. So Coulomb's law holds true for charge at rest or nearly at rest. So just remember this point as well. If the charge is in motion, Coulomb's law will not be 100% accurate there. For this, charge needs to be at rest or nearly at rest. It follows the inverse square law. And what inverse square law means? Inverse square law means that this electrostatic force is inversely proportional to square of distance between them. So any force which is or any particular number, any particular relation which you study here in physics, which is somewhat inversely proportional to the square of distance between them, such laws are called inverse square laws. Also, this is a long range force. Long range force means it can exist between the two charges lying at a long distance as well. Coulomb's law hold over wide range for atomic distances to many kilometers. This is an important one. Like for example, if there are two charges which are kept about a distance of diameter of nucleus even to different many kilometers. So this is what makes it long range force. This is what long range force means. Later on, in different units, we'll talk about nuclear forces. So nuclear forces are very short range force. So just giving you an example to understand that what is the difference between long range and short range forces. So Coulomb's law is a long range force. That is again you need to keep in your mind. So let us try to figure it out that how the force will change if these different things will be there. Like for example, the first part says if the Q1 is doubled, like if I know that this is the relation for force that we're going to use, if in this particular relation, if this Q1 is doubled, like it becomes 2Q1, so what will happen to the force? That is what we have to find. So the new force I am representing using F dash. So if Q1 is doubled, so I can say it is going to be twice of Q1 over R square. Distance remains same. So what will happen to the force, or how can we say that how force will change? So we can simply see that it becomes the twice of its initial value, which is this. So initially the force was supposed to be this. Later on, it becomes twice of it. So if the Q1 is doubled, the force will automatically going to be doubled. That is going to be act between the two charges. Next part it says what happens if Q1 and Q2 both are doubled. Now I guess you can answer it. If Q1 and Q2 both are doubled, what will happen to the force? Tell me.
The force will be R will be doubled.
I'm simply asking if Q1 and Q2 are doubled, like Q1 becomes
Yeah,
2Q1 and Q2 becomes 2Q2. So what will
yeah.
happen to the net force?
The net force will be doubled, I think.
Think properly. It becomes 4 times. We just
Okay.
have to substitute the values and just we have to analyze that what is going to happen. In the next part, the question says R is doubled. R means this particular distance between the charges is doubled. So the distance between the charges is doubled. Let's see what happens. So K Q1 Q2 by in place of R we'll write 2R whole square. Now this is a square, remember this. So K Q1 Q2 by in place of 2 we are going to have 4 because 2 square 2 is 4. So here we can see that the force is going to be 1 by 4th of initial value. So if the distance between the charges will be doubled or the distance increases, force will reduce. And this is what is represented by this particular relation. Force will be reduced to 1/4 of its initial value. Another case, if R becomes root 2 times. So again, if R becomes root 2 times, we'll simply substitute the value of R as root 2R. So K Q1 Q2 in place of R square, we'll write root 2R whole square. So here we are going to have K Q1 Q2 over root 2 square is 2. So we can say that the force will be reduced to half of its initial value. So these are the few cases where you can analyze that how force will change if the charge and the distance between the charges will be changed. So again, important thing that you need to remember. Clear?
Yes.
So again, we have to practice so many questions here, and we'll try to figure it out how force will change in the given problems in the all the given problems. So again, the next question says the initially force between the two identical charges was F. Then 50% of one charge is transferred to the other charge. Final force will be. Now this is a tricky one. Just try to analyze what is going to happen here. So initially there were the two bodies. I assume they are separated by some distance r and the charges are identical. It's given. So I'll say it is Q and Q. Now what happens here is the 50% of the first charge is transferred to the other one. So 50% of this charge will be transferred to the other one. What will happen to the final force, final charges? So we'll reduce the 50% of this. So if we reduce the 50% of this, it will become Q by 2. Similarly, if it gains 50% of it, it becomes Q plus Q by 2. Right? So the final charges for both the case for both the charges will be it becomes Q by 2 and it will become 3Q by 2. Now the question is how the charge will how the force will change or the final force will become. So initially we can assume that the force was supposed to be KQ square by R square YQ square because it was identical initially. But finally what is going to happen here is we'll write in place of Q, we'll write Q by 2. In place of Q2, that is the second charge, we are going to write 3Q by 2 over R square. So as the question says nothing about the distance change, so we'll just keep it as R square only. So here F dash is going to be KQ square by R square into 1 into 3 by 4. Just look at the problem carefully. So we can say that the final force will become 3 by 4th of initial force. This is what will happen to the value of the force when 50% of charge is being transferred from one charge to the other charge. Whatever method it is there, we don't care about it. But yeah, question says the charge has transferred. So we'll say it will be transferred like that. So does this make sense? Let me know. Let's move to the next
Okay.
question and you'll be able to verify it. So this is a very simple question. Now you just have to think analytically. Although there are few things that I need to tell you. The two charges 10 PC. Now what this PC means? PC means picocoulomb. So picocoulomb is simply you can say 1 PC is equals to 10 to the power minus 12 coulombs. So this is conversion. Simply like 1 meter is 100 centimeters. So it is like 1 PC is 10 to the power minus 12 coulombs. So you can remember it. It will be useful. So now just try to think it very carefully. The question says that there are two charges. One is 10 PC, 10 picocoulombs, and other is 5 picocoulombs. So question says that they are separated by 20 centimeters. So what is the ratio of Coulomb's force experienced by them? Now what does it mean? It means that whatever force this 10 picocoulombs is applying on 5 picocoulombs, what is the ratio of the force applied by this first charge to the second charge on the first? So first of all, let us try to figure it out that how force will act here. So we know that both charges are positive in nature, so they are going to repel each other. So if they are going to repel each other, one will apply force in this direction and this will experience force in this direction. Like for example, this 5 picocoulomb will try to push it away. So I can say this is force on first charge due to second one. Similarly, this 5 picocoulomb will again be pushed by this 10 picocoulomb in this direction. So this is going to be force on second charge due to 1. This is how we actually write F12 and F21. This is a vector quantity, force is a vector quantity, so we have to keep the direction of the force. So we have to find the ratio of these two forces, F12 and F21. We already discussed this. Think once and tell me what is the ratio of these two forces. See, I just told you this thing in the earlier slides that whatever force this 10 picocoulomb will experience due to this 5 picocoulomb will be same as that of whatever force this 5 picocoulomb will going to experience due to this 10 picocoulomb. And we already mentioned in the previous slides, like if you just see it, this one, F21 is always equals to negative of F12 because the force they are going to apply on each other, they are going to be same in magnitude. But as it is represented by negative sign, so they are opposite in direction, but the magnitude is going to be same. So the ratio of these two forces will be 1:1. So remember this. This can be asked.
Okay.
This is a very basic question, and you need to understand whatsoever forces you are going to learn from laws or whatsoever forces are derived from laws, they always have ratio 1:1. Just keep this point in mind. Let's move ahead. Now you can do this question. Try to figure it out. So the question says, what is the magnitude of electrostatic force between the two charges of 1 coulomb each when they are separated by a distance of 1 meter? So just try to figure it out. You just have to apply the relation. All the things is given here. There are two charges. They are of 1 coulomb each and they are separated by the distance of 1 meter. Now the question is, what is the magnitude of electrostatic force? Let us try to find the force. Simply apply the formula. The force, electrostatic force has a formula K Q1 Q2 over R square. So K has a value, I already told you, it is 9 into 10 to the power 9, where this Q1 is 1 coulomb, Q2 is again 1 coulomb. Distance between them is again 1 meter, that too square. So what we are going to get? We are going to get 9 into 10 to the power 9 newtons. This is what the force will be there. The very simple question, but from now the level of question will increase. So try to understand and try to apply the relation well. Should we move ahead?
Yeah.
So two charges of one stat coulomb. Now in the first class, I told you that stat coulomb is another unit for charge. Although you don't need to remember it, but yes, that question might be asked, like not that much chances, but yes. So the answer to this question is going to be 1 dyne. Remember the answer. That's it. Now, what is dyne? Dyne is the CGS unit of force. We don't need to go deep into it, but yes, you can remember it this way only. Let's move
Okay.
ahead. Now, this is a simple question. Here, you have to find that if this charge Q is divided into two parts, like whatever way is possible, you can do it. So, the question is saying in which of the following case the force between them is going to be maximum. So in each case it's given, the first option says when charges are divided equally, like q by 2 q by 2 each. In the second case it says q by 4 and 3q by 4, so that is another way of dividing the q charge. And third case says q by 3 and 2q by 3. Now what you can do here exactly is you can find out the net force in each case by considering the value of q1 and q2 like this. So q1 and q2 will be same in this case. That is first one. q1 is equals to q by 4. q2 is equals to 3q by 4. Second case, here this is going to be my q1, this is going to be my q2. So what you have to do is you have to apply the relation of electrostatic force, which is k q1 q2 over r square. So you have to just figure it out that in out of these three options, which option will give us the maximum force. Let us try to find it out. So in the first case, F is going to be K q by 2 q by 2 r square. So in this case, force is going to be reduced to 1/4. In second case, force is going to be K q by 4 3q by 4 over r square. So I can say that the net force is going to be F 3F over 16. In the third case, it is going to be, I'm writing it directly now, F dash is going to be twice of F by 9. Now just evaluate all three answers and tell me which one is greater, F dash 1, F dash 2 or F dash 3, which is the bigger value. This is what you have to find. Tell me, you can do it. Which value is bigger? F1, F2, F3.
F4.
Which one?
F over 4.
Yeah, that is the first one. So you can say in the first case, it is going to be the maximum value. But that is not the correct answer. The correct answer is none of these. Why? Because there is another case at which, yeah, in which if we divide this q in two parts, we are going to get the maximum value. I'm not going into that because it involves some part of calculus, and I don't think so it should be required in your case. So just understand these three cases. This is enough for as per the AP exam is required. All right, let's move ahead. So this is your homework. You can try this one out. Simple one. Again, the question here is given. The charge of the small sphere is 0.4. Now, what this unit? This is called microcoulombs. So always remember 1 microcoulomb is equals to 10 to the power minus 6 coulombs. So question says that there is electrostatic. You have to find the electrostatic force between the two charges. No, it's given. Force is given. The two charges are also given. 0.4 microcoulombs and negative of 0.8 microcoulombs, and also the force is given. Question says what is the distance between the two spheres? So what is the distance between the two spheres? Again, you will apply the formula K Q1 Q2 by R square. So if as this formula is concerned, you have given F, you have given Q1, you have given Q2. Also, you know the value of K. So this can be easily found out. So you will try it out also. In second part, it is saying what is the force on the second sphere due to the first one. So whatever answer, whatever force is given in the first case, that is 0.2, it is going to be the answer of this particular part. So you can try it out later on, and here you have to find the R only. Understood?
Yeah.
Again, new question. So just tell me one thing first. Do you have any idea about these vectors? Like it is given the position of two charges in the space, which is represented by 2 I cap plus 3 j cap plus 4 k cap. Do you have any idea about these positions?
No.
All right, let's leave this one because if I don't think so, it will be there as you haven't learned it before. If it is required, we'll study. If you find any question in your assignment on your school book, like this particular problem, so we'll discuss it. As of now, let's leave it and move ahead. Now, these are the things that you need to understand. That is, dielectric constant is also known as relative permittivity, or you can say, which I already told it is represented by K. So for vacuum, this K has value 1. For air, its value is almost about 1.0054. For water, it is 80, and for metals, it is infinite. So dielectric constant has infinite value for metals. This can be asked. So just try to remember these four things because these are very basic things that we can easily remember. Now the question says if the force between the two charges in a vacuum is denoted by F, what will be the new force when the charges are placed in a medium with a dielectric constant K? So I already told you. So F in that medium is going to be F over K. Just remember the relation. In whatever medium we are putting our system, maybe it has some dielectric constant, maybe not. So that dielectric constant will actually reduce the force. So whatever medium we are actually dealing with, that medium will actually reduce the force by simply dividing the force by the medium's dielectric constant. That's it. You can directly remember this particular thing and use it as well. Let's move ahead. Now, this is interesting and this is important. I have seen the book and so many questions were there related to this particular phenomena, I can say. So, forces between charges follow superposition. Now, what this superposition means, let us try to understand it. Now, let me assume that this is one force, one charge. I mark it as first. This is second charge, this is third charge, this is fourth charge. Now, all these charges are capable of applying force on one another. But as of now, I am simply assuming that whatever force this first charge is going to experience because of all these charges present in its surrounding will have a suitable or a particular direction. Like for example, this first charge will experience force due to this second charge in this direction, that is away from it. So this is can be represented by F12, force on 1 due to 2. We'll represent it using vector quantity. Why? Because it is a vector and it always have direction. So force has a direction, so we'll apply it this way. Similarly, this third charge is also applying force on the first charge. So this particular direction can be represented as force on 1 due to third one. Similarly, the fourth one will also apply force on the first charge. This is going to be F14. Now the superposition principle says that if you need to find the net force acting on the first charge, it is always equals to the vector sum of all the forces that is acting on the first charge due to the other present charges in the system. Now this is not something you can add directly. This is vector sum. So this is something which you have already learned in honors physics also, where you have talked about parallelogram law of vector addition or triangle law of vector addition. Do you remember these two things?
Yeah,
So we are going to
not
apply
the
that,
parallelogram.
but you know the triangle law, right?
Yeah.
They both are same. It simply says that the figure which we obtain, they are different, although the
Okay.
result is same. Let me just give you the idea once again. So whatever net force we have to find, it is always equals to F1 square, F2 square plus 2 F1 F2 cos theta, where this angle is the angle between the two forces, and this is the magnitude of it. So this is what triangle law and parallelogram law gives us. So we'll apply the same in some of the questions. Let's see some of those questions. So let's skip that one also, because it in this case the direction of forces need to be recognized using these position vectors. These are basically called position vectors, but let's not go into it. Let's move to the next one. A very simple question. And these kind of questions will be there in your exam as well. So the question says find the magnitude of force on indicated charge particle in the given case. So what is the force this particular system will exert on this marked charge? So here you can see, now let me just mark the names so I can assume it is my first charge, this is my second charge, this is my third charge. So the first charge will experience force due to the second and third one, both, right? And as you can see, the both and all of them are positive in nature. So the force which will exist between any of these two will be repulsive. That is also you need to understand. All right. As the distance between each charge is r, so which type of triangle we are getting from this particular configuration? Tell me. Which kind of triangle is it?
60 triangle.
What we call it? Like name.
I'm not sure what the name is called.
Equilateral triangle.
Yeah.
A triangle which has all sides equal as well as all angles are also equal. So all the angles are going to be 60 degrees as well as all the sides are also 60 are like the same one.
Okay.
So this Q will exert force on this Q as well as this Q will also exert force on this first one. So already we know that the force will be repulsive. So this second Q will exert force in this direction. I can call it as F1. Similarly, this third Q will exert force in this direction. I can call it as F2. Let us find out the value of F1 and F2 individually. So for finding the value of F1, just observe these two charges. So it is going to be K Q Q over R square. Similarly, F2 is also going to be K Q Q over R square. So it is going to be K Q square over R square. And next one is also going to be K Q square over R square. I can just mark it as F. So these two forces, that is F1 and F2, are same in magnitude, that is F. Now just try to tell me what is the angle between these two forces, like this angle. What this angle is going to be. What this angle is going to be. Tell me.
Okay, 60.
Yeah, 60. These are vertically opposite angles. So now we know the angle, now we know the force. So the net force acting between the two, acting on this particular marked charge, it is going to be F1, that is F square. We have to apply the resultant formula. F2 square, 2F1 F2 cos 60. What is cos 60?
Uh, Negative -0.9.
No, it's 1 by 2, half. Try to remember all the values because this is not something which is going to be there in the question paper.
Okay.
So the answer is going to be root 3 times F. Or you can say, we don't have to write F here, we should be writing the value of F, which is going to be this. So root 3 times KQ square over R square. So this is the net force which will be acting on this marked charge. This is what is being asked in the question. Is it clear?
Yeah.
So now this is all about Coulomb's law. As the complexity of the question increases, maybe through you can say calculation point of view, maybe through the given data, but the process of solving the questions will remains the same. There are so many questions in this file, and I want you to try these questions as much as you can. You have enough time for the next 3 days. At least try to solve 5 questions each day. Similarly, you have book also with yourself and you got the assignment in the last class. So in the assignment also, same or these type of questions are there. So instead of solving these questions, I will suppose or I will make sure that we solve those questions which are there in your book because these are going to help you in that case. So this is all about this particular chapter and this particular part of this chapter to be precise. I'll share the whole PDF with you and make sure you try some of these questions.